Okay, we're ready to get started. Appreciate everyone being here and welcome you to our September CSRIC meeting, and look forward to a good, productive meeting today. Before we start, I'll turn the meeting over to Jeff Goldthorpe for a few comments.
Okay, thanks, Glenn. We're waiting. We were waiting for David Tretzky. He'll be here momentarily, and so we'll hold his remarks until he gets here, but we'll proceed with the meeting just the same. Today, first of all, before I start, I'll welcome you all here, just as Glenn did, and the reports that we have to look at today are from Working Groups 3 on location accuracy, 4 on network security best practices, 6 on secure routing protocols, and 9 CAP migration. So 4 reports today, and we have readouts from the other working groups. Some of them will be on the conference call. Working Group 5, which does not have a report for vote, will go first, just for scheduling reasons. So that's the plan for today. You should have either an agenda in front of you. There's agendas over on the table where you came in, and the reports were all distributed for review prior to the meeting today, and you had a chance to review them and give your comments. So thank you again for coming today and participating in the process, and I'll turn it back over to Glenn so we can get on with the meeting.
Thank you, Jeff. Before we begin, I just want to take a moment to recognize that thousands of people in the country were impacted by a number of extraordinary events this summer. There were disaster events. First, there was a fast-moving storm called a derecho, which I'd never heard before this storm came through, but did an amazing amount of damage. Came through the Midwest, into the Mid-Atlantic, and the Northeast. It caused millions of citizens in these areas to be without power. It was amazing amount of damage. In the middle of a heat wave, they were without air conditioning, and the storm caused billions of dollars of physical damage across the country. It had significant adverse effects on communications capabilities, including 911 facilities. So that was the first major disaster. Then we had the fires that started in the early summer. They really took off in June. They were driven by really high winds, very brittle conditions, primarily in the Southwest and Midwest. These fires claimed lives. They destroyed hundreds of thousands of acres. They damaged and destroyed homes. Again, left millions of people without power. Then most recently, in the disaster that I saw somewhat firsthand, was Hurricane Isaac. It impacted people in Alabama, Florida, Mississippi, and my home state of Louisiana. It was a Category 1 storm, but it claimed lives. There were heavy rains, amazing amount of flooding in our state and in Mississippi especially. But a tremendous amount of damage as well, with billions of dollars of damage to homes and businesses and crops. And while on the surface these issues may seem far removed from the work we're doing here, I think it's important for us to remember that the council's purpose is to ensure communication systems remain secure and reliable today and also in times of these disasters. So that's a lot of what we're about here in times of disaster. We want to have reliable communication systems. Important for the security of our nation, as well as just the continuation of business and making our country great. So with that in mind, today we'll continue our forward momentum with the 4 working group reports that David just mentioned earlier. As we've done in the past, following these reports, the council will vote on the reports, and then once these final reports are given, the remaining working group reports will be reviewed. As David's not here, we'll move forward with the reports. I want to say first of all, Sue has a clicker. Where'd Sue go?
She's right here.
Here she is. She has a clicker available. She'll be happy to bring you the clicker. You can move your own slides. She'll move them for you at your direction, whatever you prefer. We'll move in the working group presentations. Generally, we review the final reports first, but due to a scheduling constraint today, we're going to ask Working Group 5 to provide their status report before we go to the final reports. So with that in mind, I'll ask Steve Crocker with Working Group 5 to have his report.
Steve's on the bridge.
So this is Steve Crocker. Thank you very much, Glenn. And thank you all. I appreciate the courtesy. I'm out in California and have early morning meetings scheduled, and so this is squeezed in even before. So this is not a time when we have a report to present. We are actively working on our next report, and we'll deliver it for the December meeting. We delivered a report in March that laid out levels of implementation for DNSSEC for ISPs, and we're now working on the measurement, the methods of measuring the uptake and dispersion of DNSSEC validators in ISPs. So that's effectively all that I have to say. Happy to answer questions, and again, very much appreciate the courtesy.
Any questions for Steve? Steve, I think you gave us some time back there, so thank you.
Thank you, and I'll drop off at this point.
Okay, with that, we'll begin the discussion of the final reports and recommendations. First of all, Working Group 3 on 911 location accuracy, Richard Craig and Steve Wisely.
Good morning. On Working Group 3, just want to give a verbal update. Since our meeting back in June, the work group has had one face-to-face meeting since June. Another one is planned next month. The work group has been meeting on conference calls at least twice a week on the various components. You'll recall back in our meeting where we had our report on indoor location testing approved, we talked about the testbed plan. That was a proposal, and Richard's going to be talking about that in a second. Our other part that we have as a subsection of our responsibility is due in March, and that's the leveraging of commercial base location services. That group is progressing along, and as I said, they'll have another meeting face-to-face within a month. But this morning, for your approval, Richard Craig is going to review this whole testbed proposal concept. And Rich?
Have the deck up. Okay. Thanks, folks, for the opportunity. So as Steve said, I want to talk a little bit about the testbed concept. We've been working on it for quite a while. We think we've got it pretty well nailed down, and here's our opportunity to present it to you and get you to sign off on it. It includes a number of elements. Let me kind of start off with sort of a high-level overview. First of all, the obvious goal is to be able to give the FCC complete and full answers to some of the questions they asked the work group for. And in order to do that, we feel like the testbed is the answer to getting those questions addressed. And in order to put a little bit of a framework around it, let me kind of give you a sense for how we're approaching it. So first of all, recognize the need to be testing in morphologies that represent the larger environment around the country, and those morphologies that we think represent sort of, the places where we could typically expect a caller to use their device and dial 911. And again, trying to get a representative sample that can be used nationwide. And then, of course, we want to test in buildings where we can expect people to use their device, not only in those buildings, be they either commercial or private, but also in the various different construction types. We know that performance is a function of the materials and the construction in the building, so we want to make sure we've done an adequate job of testing in all the environments where we can expect people to use their device, including the different types of buildings. In terms of the number of test points, we have some goals around the number of test points as well as how those test points will be established. The idea is to establish a common set of test points that all technologies would get reviewed against, thereby leveling the playing field. And also, our goal with this is statistically valid sample sizes consistent with testing methodologies and ESIF and as developed by the work group. We've got a deliverable in March to produce a final report for the FCC, so time is of the essence, of course, and ultimately the number of test calls we take at any given test point will be a function of trying to accomplish statistical validity and still get the job done and the report delivered by March. And then finally, we recognize the need to have an independent entity really take charge of the testing, sort of be in control of all the information that could be sensitive and proprietary, and basically sort of act as an independent arm of Work Group 3, but be able to get the job done in an independent way, in a way that we can all be comfortable that we're going to get a valid result out of. So that's the approach. Let me jump to the next slide here. So what are some of the benefits of that? In our mind, there's probably three major categories of benefits. One is objectivity. From our perspective, having the performance data independently and objectively collected makes it useful to the whole industry. The idea of having a blind selection of the test points and have those test points be commonly used for all the technologies that will be tested gives us, again, I talked a little bit about the level playing field, but it also puts us in a position where folks don't have an opportunity to go in advance and sort of set up for the best possible performance. We're really looking for real life, real world type performance. And the way I think of both of those things is, I guess in my own organization, I want to talk to the engineers, not the marketing people, right? I'm looking for that kind of data, right? And then, in terms of the trusted third-party administration, I think the objectivity is obvious there. Common methodology across technologies, and then again, the broad range of morphologies trying to represent the larger universe in the U.S. From a cost savings perspective, there's some benefit, at least in phase one, because we're taking 6 or 7 technologies through the process at once. And we have 4 participating carriers involved in that. So it allows us to do a fairly large volume of work at one time, set up the test bed, get it up and operating, and then run the technologies through it. There's some efficiency that we gain there from a cost savings perspective. And then in terms of the results, and to me this is the biggest benefit, is that the FCC, all of the industry players, and all the technology companies get an opportunity to share the results and determine, how do these things perform and what can we expect, which is the ultimate goal. Now, we envision setting up the test bed and doing having really 2 stages. Stage 1, of course, is all the work that we're going to do with existing technologies or technologies that either exist or are very close to being ready for prime time. And to take those all through the test bed, and when we complete that, get a report out to the FCC that attempts to address the questions they asked us in Work Group 3. So that's phase 1. We intend to have that report delivered by March. Got a lot of work between now and then to do, but nonetheless, that's our goal. And then stage 2 really is we wanted to have this test bed get developed in such a way that it could survive this work group, this CSRIC, and perhaps become something that the industry could use on a going forward basis to do the same kind of thing, the same methodology, perhaps tweaked as necessary to answer any future questions the FCC might have around it, but nonetheless create a framework that was repeatable and that was reliable to get us good information about technology performance going forward. So in our mind, stage 2 is something with the test methodology we developed, with really the whole structure and approach to doing it, the process. It is something we could pick up afterwards, either with CSRIC guidance in the future or perhaps in some independent way. So that's where our thinking is. And of course, in stage 2, we'd be looking at probably technologies that were a little bit further over the horizon, maybe things that were just starting to surface that we think might have some potential benefit or might solve a particular problem we're trying to solve with regard to accuracy. So that's kind of what we're thinking. In terms of the companies that are participating, I've got a little bit of a typo on this slide. I've got Boeing listed twice. But we recently polled all the companies to determine their commitment, not only financially to setting up the test bed based on the dollars we thought we needed to get in place based on our estimates to actually get phase one done, but also their interest in having their technology be reviewed via the test bed process. And so this is the list of companies. I'm pleased to say that everybody on this list has agreed to participate. And so I think based on this commitment, we're going to be able to fully fund phase one, which was our immediate goal, obviously. So good news there. As you can see the list as well as I, but a lot of good participation. And I'll say also, besides any financial commitment to fund the test bed, most of these companies are really, in many cases, putting their day job on park in order to get the volume of work done that needs to get done to kind of set this up. So there's a fairly significant investment in time and talent that we're tapping here, and it's a good team and they're doing good work. So I'm pleased to represent them here. Okay, so let's talk a minute about the funding model. Lots of challenges with trying to set something up like this with as many companies involved as you might imagine, and figure out how do we write contracts around it, how do we protect people's proprietary and confidential information. Some of these are new technologies. How do we do this? In my mind, one of our chief concerns was how do we do this in a way that we could all, at the end of the day, pass the red face test, that it was an independent and objective study, and then it was done all above board. And so that was what our thinking was as we went into it. And then I guess the second part of our thinking was how do we even accomplish it given as many moving parts as there are involved in that and setting it up. And so the simplest model, and based on some consulting with the FCC, the simplest model seemed to be that we would develop a request for information for the testbed company, and we'd go out and we'd select companies from a list of companies that we knew to do this business and we all had some experience and success with in the industry. And then we would set up and we would write a contract that test house would contract with any company who was interested in having their technology evaluated, would use the standard contract, perhaps some of the T's and C's being a little different, but the scope of work associated with the testing, the methodology, all the structure and framework that gives us the objectivity we need to get the results would be baked into that agreement and baked into the scope of work. And so, again, in an effort to get something that not only we can accomplish for phase one, but could be a repeatable format and framework for going forward, that seemed to be the best way to approach it. So that's what we've done. So and I'll get to the schedule in a minute and tell you where we're at with that. But so the way this is going to work is we're going to have an independent company. We're going to select them through an RFI. We're in the process of doing that right now. Then each testbed company or each company who has the technology to be tested will contract with the test company either independently or perhaps with a carrier partner. In the case of Verizon, for instance, we'll be partnering with Qualcomm. And then those companies will contract together to do the work. In terms of how all the information is going to be managed, again, in terms of proprietary confidential information, the goal is to have the independent test house do all of the work on the information that's proprietary. They're going to have all the ground truth information. They're going to have all the technology information. They're going to act as the independent, arm's-length third-party organization to work to set that test up under the methodology we've prescribed so that it can be successful and it can produce the kind of results and deliverables that we specified in the scope of work. And so each one of those will be handled in that way. Okay? And then in terms of information that comes out of that, all of the carriers who are participating are going to get a chance to look at the raw data. But the technology companies, who of course are potential competitors with each other, are only going to get to see the data, the raw data, from their own tests, so that they can evaluate those. Okay, and then of course, carrier any information the carrier is going to get is going to be under NDA, and then finally, we're going to produce a report that will be cleansed of all the proprietary information that is ultimately attempting to answer the questions the FCC is asking. That report will come back to the work group and basically give us what the data suggests, right? Gives us the raw data. And then work group 3 will endeavor from that point to add a little bit of color and shape around it in terms of what we think about the potential feasibility, implementation, what's the likelihood of these technologies being successful and in what areas are they going to help. So we'll add a little color to that, and then ultimately we'll deliver that report in March. Okay. Finally, to the schedule. I won't go into all the detail here. Suffice to say, we're in the third quarter. We're literally just finished up the RFI to send out. In fact, I think it's been sent out. We've gotten responses from some of the test houses that they're interested in. We'll be submitting a proposal, and we are really just trying to get all of that setup done. We worked on the contract and finished that up, I think, on a call the other day, and hopefully have that in final form. That'll need to go through some legal review. But again, we're trying to get an agreement that everybody will sign up to, and kind of put everybody on notice that we don't need to wordsmith this thing to death and we don't need to lawyer it to death. We've got to make sure that it passes muster, but ultimately we've got a March deadline here. And then, of course, in the fourth quarter, we plan to actually get into the testing process. We've set up a group within Work Group 3 of 3 technical experts who really are our technical gurus on the group, and who don't represent the technology companies. There's 2 carrier representatives and 1 PSAP representative on that group, and their job will be to answer all the questions that come in from the testing house and the technology company as they go through that process, because undoubtedly there will be a lot of necessary technical interaction to make sure we're going to get the result we're looking for, and we wanted to set that up and do it in a way that we could meet the March date and we could have the right technical people paying attention to it, again, but being sensitive to proprietary and confidential information of some of the different technology companies. And then finally, of course, as I said, we're going to produce the report. We're going to look at the data, and then we're going to put a little color and shading around it, and we're ultimately going to deliver a report to the FCC that will be part of the public record, and we'll take the best shot we have at characterizing the performance of these technologies, and in my mind, hopefully, again, the whole industry will be sort of on a level playing field, and all working from the same set of assumptions on what works and doesn't. So that's my presentation for today. I guess at this point I'll open it up for any questions.
I have one question on looking at the various test beds and the locations for it. If you look at some of the pre-existing test beds, for example, Idaho National Labs put together a whole bunch of communications test bed areas. It might not test all of the kinds of, for example, a skyscraper kind of environment, but there are some areas that have put in test beds that might be leveraged that could potentially reduce cost.
Honestly, we didn't. We took the ESIF testing documentation and we created an approach to testing that attempted to accomplish the things that we talked about, that being the morphologies, the building types, the building construction material types, and we tried to pick an area in the country that we felt had all of those things in it, would be logistically possible to do in the time frame we were operating in, and might have enough structures, either government, retail, etc., that would give us enough buildings to be successful in convincing enough building owners to allow us to use their buildings and be able to accomplish the amount of testing we felt we needed to do over about a 1-month period. So that was kind of our approach, but we didn't talk about other test beds.
Are you planning on trying to simulate a large event, or are you just going to be looking at individual events?
Are we trying to simulate
a big 911 event where you'd have a lot of calling out from a location?
No, we did not envision trying to deal with any sort of a mass calling event or anything like that. It's really just we're trying to represent what the average caller will experience when they place a 911 call indoors in various environments.
Yeah, you'll have to couch the result, obviously, because that changes the location accuracy, right? A big event would have a big impact on some of the technology.
Well, a big event would have some potential on yield and on how many calls got delivered during that event, but it wouldn't have a whole lot to do with accuracy. Accuracy is really what we're about, and determining accuracy is more of a scientific effort than dealing with mass calling events and whether or not we're delivering every call to the PSAP. Make sense? Okay. Well, if there's no other questions, thank you very much, and we'll put this up for vote.
Thank you, Richard. Appreciate that. Any other questions, comments here? All in favor of adopting the report and moving forward in the direction that Richard mentioned, say aye.
Aye.
Any opposed? Motion carries. Thank you very much. That's a very interesting advancement in 911, and I appreciate the work this group has done on that. Patrick Donovan is going to now speak on.
Yeah, thanks, Glenn, and thanks, Jeff. Just a quick note. My name is Patrick Donovan, and I'm an attorney here in the Public Safety and Homeland Security Bureau at the FCC, and I am the liaison to CSRIC Working Group 3. And the Bureau recently briefed the chairman, Chairman Janikowski, on the upcoming test bed, and he was very pleased to hear that it would be taking place and very excited about it. And so he asked that we put on a workshop to highlight the upcoming test bed. And so the workshop will be taking place here in the Commission meeting room on October 24th. And I've already spoken, David Firth and I have already spoken with all of the vendors that are participating, and we expect that they'll all be able to make it and participate in the workshop here at the FCC. If you need any additional information, David Firth and I are the points of contact for it. We'd be happy to answer any questions you have. And the Commission will be releasing a public notice, hopefully next week, announcing that the workshop will be taking place on the 24th. It probably won't include many details at this point, but we will be releasing that public notice next week. And thanks again to all of the work of CSRIC Working Group 3 so far. And then I'd especially like to thank Steve and Richard for all of their work. Thanks so much.
Thank you, Patrick. David Dreske has joined us, and David, thank you for being here. And of course, David is Bureau Chief of the Public Safety and Homeland Security Bureau, and we're glad to have him as part of our group here and help lead this group. And I'll turn it over to David this time.
Thanks, Glenn. On behalf of Chairman Janikowski and the Commission and the Public Safety and Homeland Security Bureau, I want to welcome you all back and thank you again for your continued work and hard service. There is no question that this group is unique and makes a unique difference. We had a meeting yesterday with some international players, another government, and in talking about the different ways that we do business, one of the things that we got to talk about on the U.S. side was the cooperative and interactive kind of process that we model here today, and your hard work has made one of the most worthwhile things that go on in government. This is just such a unique forum with people from throughout the government, not just the FCC, but other agencies, people from the business world and elsewhere. This is an ideal way to try to make progress on some really hard problems. And progress is indeed what you have made in the area of our business, communications security and reliability, which is an important mission of the Commission. You've made a real difference, whether it's from the security side, where this multi-stakeholder model has produced an anti-bot code of conduct, endorsement of new steps toward implementing security improvements to the domain name system, the routing work that you've done. Those are just some examples on the security side. Patrick was talking a moment ago about some of the work in 911. The work on improving location accuracy is just another example of what's vital. The next generation 911 issues are important, and we're reminded so by not only the fact that consumers are carrying around enormous capacity in their pockets that could inform first responders if they had that information, whether it's photos and text and videos texts or communications they could send. But it also, we're reminded of this when we see what the aftermath can be of natural disasters. I'm testifying later this afternoon before a subcommittee of the House Homeland Security Committee about the effects on 911 in the wake of the derecho. And that was serious. The outages affected a couple million people. Those outages were primarily in the Virginia and West Virginia area, but it included Cincinnati briefly and other places in the upper Midwest. Excuse me. And that just we all understand that. On the road to perfection, there are a lot of bumps, and we all understand that. But the level of bumps is much too high, and the work that CSRIC is doing and can do, I think, can make a real difference, and also can help drive us to a more resilient and reliable NG 911 architecture. And so we are very interested in all of the facets of the work that you're doing. I am personally in awe and appreciation, and have the greatest of appreciation for the time commitment, the effort that you put into making this multi-stakeholder model work. Glenn, thank you very much for your leadership, and without any further ado, let me turn it back to you, because I know you've got a full program.
Thank you, David, and appreciate your remarks. And I agree, this group has done some really valuable work. This committee, for the FCC, for the country, really, and I'm glad to be a part of this. The next working group report is Working Group 4, the Network Security Best Practices, with Rod Ramison. Rod?
Over here. Thank you, Glenn. And thank you to the committee for your time this morning. We have our first deliverable to report out today for your consideration and vote. And I would like to thank the members of our working group as well for their hard work in getting this prepared. It was a challenging summer in many ways, lots of vacations and things like that, but we managed to get the work done and present this. It was also a challenging summer when it comes to, just going off of what Glenn was talking about before, but in the DNS space, we had some very interesting things happen over the summer as well, so I think this report is very timely. We had the taking down of the DNS changer infrastructure that had been stood up temporarily, and it had effects on ISPs throughout the country and the world. We had some interesting rise in DDoS attacks, including a very massive one against one of the largest U.S. carriers that affected business customers and the like. It was a reflective DNS amplification attack, something that we addressed in the report today. We had just yesterday largest domain registrar and one of the largest hosting providers in the world and the country had a problem with their DNS infrastructure that was reported as a result of a problem in their routing infrastructure. So there's timely things that are going on right now that we actually addressed in this report. So from that respect, I think many people will find this very interesting. I'm going to go over just quickly the logistics of the working group. This is our remit here. We have the standard duration starting in a year ago up through March of next year. We have over 30 organizations represented. That has the membership has been, I don't believe we've made any changes since the last report or the last meeting of the CSRIC. So we have two deliverables. Today we're going to be reporting out on best practices around DNS, and in March we'll be reporting out around BGP and interdomain routing issues. Diving down now just a little bit, we have the report today. Over the fall and into the winter, we will be doing our draft of our recommendations around routing. We've already done some of that work in the spring. If you remember, we split up and decided to do two full sets of deliverables instead of the kind of staged reporting we were going to do originally. And we will be reporting that out in March, and we have biweekly teleconferences and then sub groups every other week on those off weeks. So much for the logistics. Let's talk about the report for today. We have, I'm going to basically go over highlights here of the report. We did some very kind of detailed analysis of various issues, came up with a lot of different recommendations around how to deal with those issues. But one of the key things we wanted to make sure that people got from the report was that DNS is a key component of services offered by ISPs. Both from allowing customers of ISPs to use the internet at all. It's the name resolution service, so that if you type in your favorite company's name or government name, it actually resolves to the internet protocol addresses that it's supposed to. And then, of course, for allowing people, businesses, organizations, government enterprises to create an internet presence and have people get to it. And these are all services provided largely by ISPs. It's also important for various other operations that are kind of more mundane and behind the scenes. I think Working Group 8 actually had included in their report on 911 services needing routing and DNS in order to be able to have those services actually operate. And that's not, you don't traditionally think of that necessarily of the thought of somebody typing in a website and going to it. It actually is the backbone of a lot of different operations out there. So it's something that needs to be resilient to attack, to misconfiguration, to outages, to all those kinds of things that are important for any kind of operation out there. But it's a key cornerstone type of service. It's also a challenge because it's a distributed infrastructure. A lot of the parts of the infrastructure are not within the control of the organizations, the ISPs themselves, that they have to deal with. DNS itself starts with 13 root operators. It has domain registries, domain registrars, various DNS providers out there that aren't necessarily ISPs in the traditional sense. And then there's a whole woven element of DNS crossing and supporting back and forth. So this is a real challenge for an individual organization, ISP, what have you, to be able to manage their risk within. And we went into some of those details within the paper. So the scope of the report is what this slide is about. I can't see it over the teleprompter, unfortunately. But the scope here, we had to be fairly narrowly defined in that we were looking at issues not regarding the implementation of DNSSEC, as that was Working Group 5's remit. So we commented a bit upon the threat vectors within there, DNS cache poisoning and the like. Excuse me. But we referred to Working Group 5's work for resolution of that. What we did look at are obviously the recursive DNS infrastructure that is provided by ISPs. We also looked at the authoritative side of DNS infrastructure that is provided so that people can have their name resolution to their IPs or how your configuration is set up as part of this, and also the domain registration angle as well, because DNS requires you to register and maintain domain names as part of the whole ecosystem. And then in general operations within network security, network operations, personnel, all those kinds of things that could affect the delivery of DNS services. So that was the scope. Some of the issues that were brought up as part of our deliberations and not necessarily all reported out on because they weren't all necessary best practices, but things that we considered. Starting at the top of the list there, were publication of malicious information, and this could be caused by any number of things from account takeovers to hacking to insiders adding entries to domain name servers, etc. So this is basically the public how somebody can get something malicious into the DNS system. And then, of course, the flip side of that is if there's bad information out there, how is that handled on the recursive side or on the resolution side? What are we doing about it there? And then if it's introduced in transit, isn't a cache poisoning attack? So the publication is fine, but somehow there's interjected somewhere within the process falsified information. Also, some related to that in a way is insecure domain zone transfers. It's a fairly esoteric DNS operation thing, but it's an area where there's some security concerns around being able to inject things that aren't supposed to be there. And then, of course, we took a long look at DDoS, distributed reflective amplification attacks, as those are some of the most powerful kinds of DDoS out there in a preferred method for various miscreants. A couple of other issues we looked at that are related are on the recursive side, was filtering or synthesized responses. So in other words, changing the response that you would get in DNS to something that wasn't published. And related to that is actually writing or creating a record where one doesn't exist. That's the NX rewriting. We looked at the issue of open recursive resolvers and their effects on security and issues. A new topic called ghost domains. We actually didn't have BCPs to report on this, but we actually added it to the report. And this was the ability for people to create ostensibly a malicious domain name, remove it from the authoritative side, but keep it alive in recursive servers for indefinitely. It's a very interesting problem to have to deal with that was newly discovered. And then looking at things like DNS Changer, where you have customers that have a virus on their computer that changes the way their DNS acts and how you respond to that. It's a major challenge. We learned a lot in the DNS Changer working group about that. Hopefully we'll be getting some reporting out from there on things we can do as an industry to some lessons learned, et cetera. Then there's some issues as well with routers that people are purchasing, putting on their home networks that have default DNS resolution paths that don't go through their ISPs, and how you deal with that from a customer service perspective. And then looking at various other DNS infrastructure resiliency issues in general, and how do we keep the DNS infrastructure working, and all the different kinds of vectors of problems that you can have there. So we divided up in the report and the analysis, we divided up into 6 different areas and did our analysis and recommendations within those 6 areas. And just from a logical perspective, how to attack this problem or the various problems and issues. So we took a look at issues with recursive recursive infrastructure, services, resolvers, etc. We took a look at in one section. Then we took a look at a similar set of issues, but somewhat different. And when you're talking about the authoritative side of DNS. On the authoritative side, you added issues in, for example, around domain registration, protection, and things like that. And then there's looked at the infrastructure that ISPs provide to their customers. The first 2 was looking at kind of the effect on ISPs themselves. The third one was looking at DNS services provided to customers. Then we took a look at things where an ISP's infrastructure could be used to attack others, and so obviously the big one there is the reflective DDoS amplification attacks. Then we did the issues around subscribers having different problems, as mentioned, DNS Changer and the kind of the router on premise having a different type of DNS path of resolution. So those are the issues that we talked on there. And then we kind of had a catch-all category, we called it hygiene and other issues, which had things like the T-SIG stuff and a couple of other issues that didn't quite fit into those other categories. So that's how we divided up the work in the report. So we ended up with numerous so our process and our thinking process here was to create a report that didn't reinvent the wheel, but actually told you where to go get the various wheels and put things in context. We ended up, I think, with a 55-page report as it was. If we'd kind of brought in all these things and added them, I don't know how many hundreds of pages it could have been. So what we did was we said, okay, we're going to take a look at the state of the art in the industry and look at documents like prior CSRIC reports, IETF, RFCs and BCPs, ICANN, SSAC reports, some things from NIST and ISOC, and we're going to refer the reader of the report to those documents to get their full context of the various recommendations that were in there. So that for example, if you had something around protecting your network, there were several different very good reports around best practices for protecting server infrastructure and the like. Refer you to those for those particular issues. And for reflective DDoS attacks, BCP 38 as an example. So that was the process we went through. We went through and analyzed those issues, found those documents, brought those in, and then referred those out. So we ended up with 24 separate documents that we referenced as part of the work, mostly IETF, RFCs, and BCPs. The highlights from that, and this is really boiling down a whole bunch of different things, but really it's pretty common sense, I think. It's to protect your infrastructure from hacking, insider attacks, account takeovers, all the various things that you're seeing happen for people to be able to either by intent or mistake have the DNS either recursive or authoritative, provide incorrect or non-existent answers or just plain disappear. One of the other highlights is and I think one that has not been talked about as much that is a major concern is protecting domain names from hijackings. This is or misconfiguration, the domain registry. This is an area where we're largely left to the devices of an external organization, but we need to be aware of the ways that we can protect our domain names and thus our DNS from those kinds of attacks. And then in general, ensure the resiliency of DNS infrastructure, just like you would any other critical service. And finally, implement BCP 38 and the related measures. There's other ones that go with that to address ingress filtering and combat reflective DDoS attacks. It turns out from the discussions in our group is that it sounds like a majority of U.S. ISPs are already employing this from the feedback we've gotten. However, we don't have control over the thousands of other and millions and billions of other, I guess, IP addresses out there that could be routed around the world. But this is, I think, important that there's a standard being set, at least within the U.S., on doing this, and that we bring attention to this because these attacks are being directed largely at ISPs or major web hosting companies because that's where the targets are lying. Here's a very long, illegible list, at least on the screen, of the participants in the working group, but it's in the presentation for everybody's for the record, I guess, and it's obviously in the report itself. So that's the highlights, and I am open for questions.
Good job. That's a really good summary. I think you got pretty accurate handle on the problem. I was wondering about the issue of capacity. What we saw all summer was, in many cases, DNS instances that see traffic like 1 meg per day or something. It's crazy, kind of, averages on a given day, seeing something like 70 or 80 gig aimed at them in a DDoS attack, which is just mind-boggling when you think of the engineering implications of an average of 1 meg having to be designed to be resilient up to 70 or 80 gig. Does the report comment on any of that at all? Because that's just, as an engineer, I've never seen anything like it in my life.
Yeah, and there's that attack was brutal. I know the one you're referring to, and there's been others in that same scale. We're seeing the 50 gig plus attacks. We did reference the issues in the report, and then pointed to there are a couple of, I don't remember off the top of my head, there are a couple of different BCP or RFCs, and I believe one of the NIST reports directly addresses those kinds of capacity and resiliency issues. That's, again, what we're trying to do within the report is bring those issues up that would be such of import, and then say here is where to go as a resource to kind of address that. I think we're also seeing just in general against DNS servers almost this background radiation, if you will, out there from various reports I see coming in from TLD operators and the like. There's a lot more just kind of noise going on being directed at DNS servers, and we're not sure necessarily in all cases why they're out there. I think it's an important issue to be planning around.
Yeah, it might be worth having some mention in there, because you're talking about 70, 80,000 X design tolerance there, which is just, unheard of.
Yeah, it's well beyond what what anybody would originally plan for.
Right. Along the same line, I'm awed by the amount of. Are we on? Hi. I'm awed by the amount of work your team did, and the topics are the right topics, and what you did was really valuable. When you look at Stuxnet, and you sort of separate the systems that run the centrifuges from the way you break into them, mm-hmm. You see that you don't break into the centrifuges. Right. You break into the systems that are touched by the people who manage it. So you break into their own systems, and then they're the ones who. So you're an authorized user now, and now you have the right to change all that DNS stuff, but you're actually an authorized user who is a malicious user. Mm-hmm. And that happens not because the centrifuges were vulnerable, but because the system of the people who manage the centrifuges were vulnerable. I didn't see where you talked about it in your talk, but I didn't see in the report where you explicitly said if the infrastructure around it is not hardened, nothing we do can protect. I don't want you to sort of throw up your hands, but where do you come down on that? Because if the infrastructure around it isn't hardened, then authorized users' systems get taken over, and those are the access method to change everything you're talking about, and we have no defenses the way the report's written. Right.
Yeah, and to kind of connect a couple of dots there too. The control mechanism for Stuxnet and many pieces of malware is actually run through the DNS, right? So you have right. So you have either a fixed point in DNS that's a command and control host name that is baked into the malware, or they have what we call a domain generation algorithm. Conficker was the big one for that, and I'm sure pretty much everybody in this room has heard of Conficker. There was plenty of press around that. But what that one did was basically generated 50,000 or 250,000 domain names every day, and those would be rendezvous points where all somebody had to do is register one of those domain names and be able to control that botnet. I think we did discuss that a little bit in the report, and there was certainly, we had some discussions about that within the working group around, do we want to start talking about issues of what you can do around that, but we didn't really delve into that in depth within the report as far as some of the measures, because there's not necessarily an agreed upon kind of BCP around how do I say don't go to these but addresses, right, whatever they may be. There's ways of doing that, but we did not really delve into that because there's not kind of an agreed upon way of doing that today. There are some methods that might be something we could follow up with separately. It's an issue that where do I come down on it? We should be doing everything we can to protect the network, whether it's a enterprise network, a government network, or even consumer grade. protecting people from those kinds of issues. But that gets into some rather interesting areas for policy and the like, and I'd like to probably address that separately from this report.
I think we should be careful in drawing analogies too far. Sorry, Andy Ellis from Akamai. With Stuxnet, you're looking at, centrifuges are the hardened infrastructure that is far away and protected, and therefore you're attacking it via its weak links. I think what we see with DNS is that DNS is the easily available, simply targetable, and very weak link, which you use to then attack other infrastructure and other communications paths.
Yes, and I think that we definitely emphasized that when it came to respect to DNS account takeovers. If you can take over a domain name, you can do a tremendous amount of damage with it. We referred to, for example, the check-free incident in 2008, where a back-end processor of almost, I believe it was like 40% of transactions in the U.S., their domain name was taken over. And instead of having the back-end transactions happen, what happened was if you actually tried to go there, you got a virus downloaded on your computer. So these can have very direct impacts, very widely spread very quickly depending on what happens. And we've had since CSRIC started last September, we've had several major web properties taken over either at the registrar or even within DNS servers themselves, services. There was a very interesting article that came out in Wired, I believe in the last week or so, about the 15-year-old hacker from Long Beach, California, who socially engineered many registrars, DNS providers, etc., had some very clever ways of getting himself into control of massive web properties just with a telephone and a few tricks on the web.
Any other questions for Rod on the discussion? Sure.
This is Jeff. Let me just suggest, too, that when folks on the phone have a question, if you could just identify yourself when you're asking, that would be helpful, okay? Thank you.
Thank you, Jeff. Any other comments? Okay, all in favor of adopting Rod's report, say aye.
Aye. Aye.
Any opposed? All right, thank you, Rod. Motion's carried and adopted. Okay, our next group is Working Group 6, Security Routing Protocols, with Andy Wogilski and Jennifer Rexford.
Speak from the front. Jen's going to speak from the front.
Okay, Jeff?
Hi, I'm Jen Rexford from Princeton. I'm going to give you an overview of the most recent report from Working Group 6, which I co-chair with Andy Wogilski. So if we just go to the quick view of our mission statement. So the Border Gateway Protocol is essentially the glue that holds the disparate parts of the Internet together. And like many of the protocols on the Internet, it's notoriously vulnerable to accidental misconfiguration and intentional attack. And a lot of groups have been working on this problem, standards bodies like the IETF, network operator community, the registrars, and so on. So our goal here is not so much to try to define new technology, but to look at deployment paths for getting some of the BGP security technology deployed in practice. And to do that, we have a really great working group made up of people from the many communities I just mentioned, the operator community, standards bodies, academic community, and so on, that are helping us work through those issues. And in fact, one thing that's been really interesting about the working group is actually been a rare opportunity for these disparate groups actually to talk together, because they don't often attend the same kind of meetings. So it's been a really good opportunity to hash out the gap between operational practice and what's going on in the standards community. So just to review, interdomain routing puts the inter in internet. It's what makes the 40,000 or so separately administered networks be able to coordinate with one another about how to reach other destinations remote from them. So the protocol itself, the Border Gateway Protocol, is really simple. One network or autonomous system tells its neighbors what destinations it can reach and over what path. and those neighbors in turn decide which route they want to use and propagate that in turn to their own neighbors. And so the information diffuses from an originating autonomous system out to the rest of the networks on the internet. So that's pretty simple, but routing policy ends up being quite complicated, and this is sort of the sticky wicket for BGP. Each of these domains has local autonomy and can decide which path to pick and whether to share a particular path with its neighbors based on its own local view. And it often doesn't have a completely accurate local view of what information is true and what information is false, making it very, very easy for someone to originate false information and have it disseminated by other unsuspecting networks throughout the internet. And we see every year several high-profile examples of this happening because the information is injected erroneously and nobody can tell that it's not true and ends up disseminating that information. So essentially, to really get around this, every solution for BGP security relies on trying to establish some notion of what is true. So the parties involved in picking routes can decide whether or not to pick a route based on whether they believe the information in it to be valid. And in particular, one kind of piece of information is which autonomous system or network or AS is authorized to announce a particular IP address block or prefix into the routing system. That piece of information would allow other autonomous systems to look at a route they receive and see if the last hop in that path, the final destination for that traffic, is the one that should be actually receiving traffic for that destination. And the different solutions differ in exactly how they establish that information and how they use that information, but that's the first critical piece, not the only step, but it's the first step in making the routing system more secure. And so today's best current practices are for individual ISPs to whitelist the address blocks that they know their customers own, that they know from maybe internet routing registries or even from just direct communication with their own customers. And it's much more difficult for an ISP to know whether information that originates many, many hops away is accurate or not. And part of the reason for that is that these internet routing registries are notoriously incomplete and inaccurate. And that's true for a number of really good reasons. One is that there isn't really a lot of control over the information that gets into these IRRs. There are many of them. Some of them are public, some are private. They have different information. They have conflicting information. The organizations don't necessarily have globally unique or meaningful names, so it's not always easy to tell what organization is responsible for a particular block of addresses. There's no authorization control over who can update the information in the registry, and the records don't expire, which means that they're notoriously stale when addresses move from one organization to another or companies merge or split. And the information in the registry can easily be many, many years old as a result of that. And so as a result, these IRRs are useful, but they end up not being sufficient to let ISPs construct filtering policies to block erroneous information because they always have to worry that they do no harm. And to do no harm, they have to be very distrustful of the information in the IRRs. So that's sort of the state of the world on the ground. Now the question is, what can we do to make it better? And one very popular topic right now is to think about solutions based on a resource public key infrastructure, or RPKI. And the idea of RPKI, this is going through the standards bodies. A number of the regional internet registries have been putting together trial or production services for RPKI, essentially overlay a certificate hierarchy on top of the hierarchy that allocates IP addresses to organizations. And this would allow us to have identification of exactly which autonomous system is authorized to announce a particular address block. So essentially, this would validate the authority to announce a particular address block into the routing system. It's worth noting most uses of PKI tend to be about validating identity. This is actually decidedly not the case here. The goal here is purely to decide whether an organization is entitled or an autonomous system is entitled to announce information into the routing system, and in fact doesn't necessarily even reveal the identity of the organization itself, let alone any individuals associated with that organization. So that's by design, to kind of separate issues from one another. So what could people do with this information if it were populated, if information about which ASs can announce which address blocks were present? There are 3 different states a particular route might be in. If an ISP is presented with a route from one of its neighbors and it looks at the last hop, that route could either be valid because the origin AS, the last hop in the path, the one that apparently originated the information about this address block, matches the information in the RPKI. Second situation is that it's decidedly invalid. There is information in the RPKI, but it contradicts the route that the ISP has just received. And the third case, and this would be very, very common in the early stages of deployment, is unknown. There's no information about this prefix, and so it's really impossible to tell whether this route is erroneous or valid. And so the way that ISPs might use this information is manifold. You can certainly imagine at the beginning of the deployment of RPKI, it might be used in a fairly cautious way, maybe just to generate an alarm when invalid information appears in the route. Over time, it might be used to depreference suspicious routes, to pick routes that do agree with the RPKI over routes that don't. And finally, you could imagine in the long term, there might be automated processes to take RPKI data and other data inside the ISP's own network to develop automatically filter lists to automatically tell the routers how to block erroneous routes. And in fact, one of the things we talk about a lot in our working group is exactly, what stage are we at now and what are the sequence of steps an ISP might go through in using this data. So with that said, the main thing we worked on in the last few months in our working group was an issue that came up in our last report and in the discussions at the last meeting, which was about the risks. Right? Having ground truth is clearly good for security, but there were a lot of concerns about whether this might compromise robustness or create new lines of attack that don't exist today. And so that was sort of the main topic we took up. So what can go wrong with RPKI? Well, certainly like any other system, you could imagine configuration mistakes, right? Somebody's entering their own data in the RPKI and they fat finger. Now, good thing about RPKI is the effect of that is limited. You can't make a statement about someone else's address block accidentally because you don't have the authority to do so. But you can make mistakes in entering your own information or just neglect to renew your certificate when it's about to expire. So that's one category of things that can go wrong. Another that we spent a lot of time on were more active manipulations of the RPKI. Can a certificate authority, due to an insider attack or a lawful order from a government or law enforcement agency, revoke or overwrite a certificate or a route origination authorization to cause another network to lose reachability to its destinations? That was the main issue. Now, first thing to say is, first of all, whether this can happen and in what way is still a subject of some debate. And how much impact it has depends tremendously on how other networks on the internet choose to use this information in the first place. If it's just being used to set off alarms, it's noteworthy. If it's being used to automatically filter information that disagrees with the RPKI, it can cause lost reachability. And so this is yet another reason that a staged deployment of this technology is important, because people need to have confidence that the information in the RPKI is correct and not being manipulated. And so another issue we talked about was whether someone would use this particular means to block access to a particular set of destinations on the internet. And if they would, one concern they might have is the collateral damage they would have on other destinations that lie in the same part of the hierarchy that's being manipulated. And so this alone would cause potentially fairly large-scale visibility of what was going on, which might dissuade parties from taking this particularly blunt hammer to be able to attack another network on the internet. One issue we're still working through is whether it's possible to do a more surgical strike, to take a particular set of addresses and block access only to them without having this collateral damage on other networks. And it looks like this is technically feasible, but we're still working through some of those technical details, and we're going to report on that in our final report. So both of these issues point to the importance of monitoring to help people when they're entering information into the RPKI to make sure they're not making a mistake. And also when people do manipulate the RPKI in either a good or a bad way, that it's very visible to the rest of the parties that are using this information to configure their routers, so that they can actually detect whether something suspicious has happened and hold parties accountable that make erroneous manipulations of RPKI. This alone will help a lot in building confidence in the infrastructure and in dissuading parties for using it the wrong way. So that was another big part of our discussion. So on to the recommendations. We have 6 recommendations. The first 3 really concern the incremental deployment of RPKI. The first, which is kind of a restatement of the main points we had in our last report, was that it's really desirable to certify number resources. We need ground truth. We need that information to be authoritative, accurate, verifiable, and public. So some of this is motherhood and apple pie, making best common practices that exist today better by making sure existing internet routing registries are up to date and accurate and public. But it also means starting to certify numbered resources using the RPKI as it becomes available through different regional internet registries. The second, and it relates to the first, is as people start putting their information in RPKI, we need to make sure we have tools that will help them recognize when they might be putting in the wrong information. For example, information that is different than the way the routing system normally behaves today, which might be a flag that someone's putting in the wrong data. Regional internet registries like RIPE in Europe already do this, so there's already known techniques for doing this, and it seems valuable in the North American region to do the same thing. A third is, I already mentioned before, a cautious staged deployment of using the RPKI data as part of vetting the configuration of a new customer to check if you're adding a new customer to your network, does the set of addresses this customer claims to have agree with the information in the registry? Does the customer even put the information in the registry, and can they in fact be encouraged to do so if they have not? A second next step would be to take information that you're getting from neighboring domains and check out of band if that information is consistent with the registry or not, without interfering with the actual operation of the network in real time. And a third and a longer term would be to start introducing this into operational practices for the automated configuration of networking equipment. And that allows network operators to gradually gain more confidence, both in the RPKI data itself and in the operational practices that would have to work around it. And so finally, the last three recommendations relate more to making sure we can handle potential risks and robustness issues with RPKI itself. As I mentioned at the very beginning, RPKI really just validates whether a particular autonomous system is authorized to announce an address block. It doesn't necessarily say what organization this is, let alone a point of contact within that organization. That kind of information is actually quite useful, though, particularly for detecting and remediating problems that might exist in the routing system. And so there are optional fields in RPKI for divulging that information, and including that information in the RPKI records is certainly useful for detection and remediation of problems. The existing IRR registries also provide a way to provide that information, and that's also useful. So it's not mandatory, but it's extremely valuable, especially in the early phases of deployment where there's a real need to be able to detect when things go bump in the night. The fifth recommendation relates to monitoring, that everybody's confidence in RPKI and the ability to adapt to changes in RPKI will be a lot better if monitoring is done in real time and made publicly available so that network operators can see what changes are being made in RPKI and detect ones that might be suspicious and make sure that their own networks are appearing in the way that they expect. So doing this in a very public and real-time manner, just as today we have real-time feeds of the BGP routes themselves, will allow people to be able to detect problems and diagnose them and fix them very quickly, and most importantly, build the kind of confidence necessary to rely on this kind of data in a more significant way in the future. And finally, the last recommendation is that we're continuing to investigate, and we think others should too, these technical and policy risks with the RPKI to make sure that there are either technical means to prevent them, monitoring ways to detect them, or disincentives to do them in the first place, to make sure that in making the internet more secure, we don't ironically make it less robust. So just to conclude, internet routing system is clearly very vulnerable. It's easy to propagate false information. It's hard to detect what's true. And as a result, there's a real need for ground truth, and resource certification using, for example, RPKI is one way to do that, and it provides a much more sound basis than we have now for detecting and avoiding invalid routes in the routing system. And just to recapitulate our recommendations, we want to make sure that people start making sure the information in routing registries and in the RPKI is accurate, and that they start exploring phased deployment of that in their networks, and start having tools and monitoring in the operator and standards community to be able to make sure the RPKI is evolving in the right way. And just to look at our future work directions, we're going to be continuing to explore metrics and measurement techniques for monitoring the routing system itself, and also monitoring the evolution of the RPKI as people start publishing and changing the information that's there. To continue exploring these risks I mentioned earlier, in particular the risks of targeted manipulation of RPKI, and finally to look at incentives for ISPs to start taking the intermediate steps towards using this data in an operational setting. And in particular to do that, we're going to need to look at the capital and operational costs as well as the security and performance benefits of taking those steps. So that's a summary of the report, and I'm happy to take any questions. Yeah.
First of all, great presentation, as usual. Good stuff. I'd like to comment on the last points that you're making around technical risk. Mm-hmm. I was wondering, did the group spend a lot of time sort of pondering the notion that this would be probably the most complex large-scale PKI we've ever tried, right, onto a BGP policy environment that's already really complicated? I would think the big issue would not be targeted manipulation, but just inability to do it. What did you guys think about that? And
Yeah,
this would be
that's
pretty
a fair
complicated.
point. That's a fair point. I think the main thing we're proposing there is twofold. One is, probably the most important one is a phased deployment, so that the information first gets populated and then used in ways that don't directly touch the routing system. So clearly the biggest risk is making those two complex systems touch one another, and in particular to do it in an automated real-time fashion. And so we decidedly don't recommend doing that in the early stages, even if that's a long-term goal, because we really need to understand better if this information is accurate and how to best combine it with other systems an ISP might already have. So I think cautious steps forward is I mean, it's a kind of a high-level answer, but I think it's quite accurate. And this monitoring is an important piece of it as well, because people's confidence in taking any of those intermediate steps is going to depend on believing that the information is reliable and accurate, so that when they do start moving towards greater levels of automation, that they're not going to get shot in the foot. Yeah.
Jen, is the group doing anything to promote the use of the existing registries that are already out there, not just the maintenance of the data in the registries, but also the use of the data in routing policies today?
So we do recommend doing that. The tricky bit there is that there are actually quite a lot of internet routing registries, and they have different information in them, and some of them are private. So certainly we encourage people to put the data in the public sphere so others can use that information to build routing filters. But I think the difficulty is because there's not an authorization model, and because stale information doesn't get expunged, there's some fundamental technical difficulties with truly relying on that information in any kind of automated way. Certainly we do encourage people to update the information, though. And an important piece is that data also includes the organizational identity of the networks that are responsible for these address blocks. And given our PKI does not necessarily include that information, it's going to be important for those registries to continue. So we don't expect our PKI, if it's successful, to necessarily get rid of those internet routing registries. Quite the contrary, they may need to coexist because they may have similar but not completely the same information. Great, thanks.
Thank you, Jennifer. So simple, I don't know why we hadn't already resolved this. It's obviously a very complex subject. It's been a very good report. Any further discussion? This Group 6? So all in favor of approving the report for Group 6, please say aye. Aye. Any opposed? Motion carries. Thank you very much. And next, our final report today is from Working Group 9, CAP Migration with Ed Zernecki and Chris Homer.
Thank you, Glenn.
Okay, I'd like to thank, are we on? I'd like to thank our fellow committee members and my co-chair, Ed Zernecki, for the work we've been doing all year. This is our third report on the CAP implementation, and as we go about peeling apart this onion, we continue to find some new challenges, some really good information, and we're working our way towards a final implementation report, hopefully later on this year. So a list of our members includes emergency managers, broadcasters, manufacturers of emergency alert systems. We have a pretty good diverse group here, as well as representatives for both FEMA and the FCC, and that list is included in the report. As I mentioned earlier, this is our third report. Earlier in March, we talked a bit about text-to-speech and device certification that had some positive outcomes, and then we came back in June to talk about audio. During this process, there was actually two working groups. We had one working group focused on, what the national dissemination of the CAP protocol and its effects from the June 30th deadline. But we also had a group of people looking at how is this going to work at the state and local level. And why this is important is trying to get everybody in sync so we can avoid things like duplicate messages and some of the challenges that are going to be met as the state and local people. And so for the first time, we're actually reporting some good information, I think, on what's going on at the state and local level. So starting off with what those folks have been working on is we were able to look at 4 case studies from different, again, diverse parts of the country and different both state and local government agencies, and what the implementation has been on their implementation of CAP and how that's working with like FEMA IPAWS at the national level. And the ones we looked at were Washington State, Oklahoma State, Teton County, Wyoming, and Michigan State. So the first thing we found, there were certainly different approaches on how the different entities even decided to solve the problem. Some groups basically came up with a plan and disseminated amongst the state participants. Other groups took a little bit longer, but they got all of the people involved in the process, and they kind of worked through the process in a more of a grassroots fashion. The next thing we found were there's a couple different ways to disseminate CAP. Of course, some are using IP protocol over the internet, some are using satellite delivery, and some are using a combination of both. And in the way of architecture, many of the states are using what we would call standalone server architecture. Some are using hosted services, and there are others that are using a combination of both. And then authentication, certainly the reuse of the IPAWS digital signature or your own end-to-end encryption. And in some cases, we even found that, certainly not in these 4 test cases, but there are those out there that are using no encryption, which is a bit of a concern. So not only did we start to find a lot of differences in how the CAP implementation was going at the state level, we did get to talk to some of the people on the battlegrounds of, well, what were your challenges? Well, first of all, if you look at the protocols, the current protocol hadn't even been developed yet. So there was one case where they started off with the original CAP 1.1 protocol. A lot of the equipment had not been tested end-to-end, so working closely with manufacturers and emergency managers and the content, the systems that provide the actual content. And so a lot of the big challenges were trying to gain consensus among the emergency management committees, the broadcasters, and all the above. And the final thing is, what was kind of common in all of the test cases is the need for training on this next generation systems. And included in our report, when we start talking about, whatever some of our recommendations, one of them is even coming up with a style guide that we think that the industry needs, so people can start looking at things a little different. So those are the things that we discovered in our test cases for state and local. And we thought it was time that we start collecting some of our best practices that we've been developing over the year. Of course, I want to mention this is not all of the best practices. We're going to continue to work on this road. I think when we first reported, we came up with a lot of interesting questions. Certainly we had some around security and reliability. We could probably use some help from working groups 4, 5, and 6 on some of those areas, but we do want to come back in our final report, continuing on the best practices and how you approach some of those things. We were unable to do that now at this point simply because some of the diversity with the actual dissemination of EAS, you have people anywhere from large organizations like DirecTV all the way down to small radio stations. So we're trying to look at that whole thing holistically. But what we do have for this month is certainly a best practice for message origination. which a lot of it has already been developed through the FEMA IPAWS system. So there's actually some training that's available, some certain tools that are available, and we want to make sure that the information is getting into the state plan, and that is being reviewed by the FCC. So that would be our best practice for message origination. Next is text-to-speech. Text-to-speech was introduced in one of our earlier reports as a recommendation of something to keep within the report and order. And at this point, we want to address some of the issues we're having with text-to-speech. Certainly, we all know about some of the pronunciation errors, but there's also some certain things that need to happen with regard to really keeping the subject short, to the point, staying away from certain contractions, and also trying to keep the message so it would read well once the text-to-speech that transcribes. And a good example of that would be things like addresses and numbers, putting the pauses in there so they read out slowly and accurately and they don't get lost in the shuffle. And part of this is actually included in our style guide at the end of this end of our report. We kind of reiterated our best practice for audio that we introduced a couple months ago, and just reiterating that in our sense of delivering CAP EAS, the audio is extremely important. If you don't have it, all you're going to get are tones. We all know that. But you can have the embedded audio, and if that doesn't work, defaulting to text-to-speech is the other recommendation. But we want to make sure that the audio is in the correct format, and we did, on an earlier report, recommend the current use of MP3 simply because that's really what works today. It works for all of the different signal paths. And finally, we have noticed both at the state level and federal level the need for some security, and the certainly for the transport layer security, use of the secure sockets layer. You could read through the details, but we have to look at these EAS decoders and encoders as kind of appliances. So having the built-in security with the handshake, with the origination CAP messages, is our way that assuring that we're preventing any eavesdropping and tampering of the messages, and that accurate messages are disseminated properly to the audience. And then going forward, as we work our way towards our final report, we want to continue to report on the real-world challenges that are facing the EAS CAP implementation today, and certainly take a look at things like security, reliability, even the physical layer. I mentioned earlier there's a lot of diversity and dissemination of CAP events, especially when you get to the state and local level. And also look at, also in this report, if you really start to read all the work that's been done at the different entities, you'll see some challenges, but you also see some great successes of really improved audio quality, improved usability, and one of the things we want to look at is to start to take the toolkit, the new standards, and how are we going to enhance the graphics? How are we going to enhance some of the messages? How are we going to start using CAP to its fullest capability in the future? So not only reporting on what's happening today, but how we're going to take this down to the future. And that's pretty much it.
Thank you, Chris. Questions for Chris? Comments? Yes.
Hello, this is Christian Vogler, and I appreciate your report. And I just want to throw in something for consideration. From the viewpoint of the deaf and hard of hearing community, there's a very big concern about the legacy as not being accessible. And we're very excited about the potential of CAP. And so I just want to ask this question. Are you aware of what's happening with caption radio?
I'll let Ed take that one.
By caption radio, do you mean the radio reading services some stations are supporting, or the text?
No. First of all, it is a pilot project by NPR, the NPR Labs, and they're using caption radio as the basis of an international ITV standard, ITU standard rather, ITR standard. So I'm throwing that in because this is a good way of over-the-air broadcast of emergency alerting systems. It is a way to preserve text information.
I'm familiar with that pilot. I saw a demo of it, an early demo of it several months ago. There is little reason, I think, why either the textual or the audio output of the FCC-required emergency alert equipment couldn't be inserted into that, what I was referring to as a radio reading service, as the captioning service.
Right. That was my point.
We'll take a look at it. Thank you. We'll certainly take a look at that as we go forward.
Other questions? Input? Okay, all in favor of adopting Group 9 report, say aye.
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 Anyone opposed? All right, motion carries. Thank you very much. Good report, Ed and Chris. Thank you. Okay, that concludes our final reports for the day, and now we'll have the group updates, beginning with Group 1 on Next Generation 911, Laurie and Brian.
Thank you, Glenn. Good morning. Mr. Fonce, our co-chair, could not be with us this morning. He sends his regards and his regrets. On behalf of the working group, I can tell you that the work that has been assigned to our working group by the FCC has been completed, at least the work that's been assigned to us to date. My last report was delivered to this body in June, so we have not met, but we stand ready for any additional tasks that the FCC might assign to us between now and the end of the charter of CSRIC. That's what I have. Thank you.
Thank you, Laurie. Okay, Working Group 2, Next Generation Alerting, with Damon Penn and Scott Tollefson.
Good morning, everyone. And we've made quite a bit of progress since we last met, and we'd like to update you quickly on what we're doing. The biggest step that we've taken forward, and I want to make sure I thank Rod Rasmussen for this, is full integration of the social media groups. And he helped us get the points of contact. I really appreciate that. That's working out well for us. As a reminder, here's a summary of our assignment. And as you can see just by glancing down, architecture, interoperability, platforms, and delivering media are all part of what we're tasked to do, as well as the technical and operational criteria and the social media. As mentioned before, this is by both David and by Glenn. This is quite a unique organization, and you can see from here some of the key stakeholders that are part of what it is that we're doing in the working group, and you can see how diverse the mission is and how diverse the group that's working on it is. But that really boils down to 42 different participants, and that, I just wanted to give you a flavor for the full spectrum of involvement that we've been blessed with as we've gone forward. Now, of these 42 participants, we're lucky enough to have about half that are going to join us today to do a face-to-face here, and then into tomorrow, where we'll wrap up our findings and start presenting our final report. But again, I just want to show you the three committees that we divided into and who those co-chairs are. And you'll see that most of these co-chairs are also involved in other committees, so quite a commitment across the board. And then our next steps, as I mentioned, the call today, and we'll continue our calls. And then we're on track for our deliverable that's scheduled on the 5th of December. But subject to anyone's questions, that's what we have.
Thank you, Damon. Any questions for Damon? All right, Working Group 7, the botnet remediation with Peter Fonash and Michael Reardon.
Hi, good to be here. So basically, we've had 3 tasks, one of which was to produce an initial code of conduct. Now, that code of conduct has actually been produced, and it's been adopted by ISPs representing 86% of the subscriber base of broadband subscribers in the United States. So it's fairly broad adoption, and really now the challenge is for us to move on to the second and third phases of the work that we've been charged with. The second phase is for us to identify the barriers to code participation. And a subgroup's been set up to do that, where we're looking at the various things that will stop the remaining 11% of the ISPs from actually getting involved in this code. And so that work's going ahead. We anticipate having a spreadsheet outlining the details of the challenges that the ISPs face by the time of the final report in December. On the third bit, which is the development of bot metrics, I just have to be absolutely brutal. That's proving considerably more challenging. ISPs are collecting bot metrics. They're collecting them in different ways. They're coming up with different results and different numbers. And I think that's going to be a real major problem going forward, because it's very hard for the ISPs to really even agree amongst themselves what constitutes a bot, what constitutes an infection, what constitutes cleaning. And this, I think, is work that should go on both maybe in the next CSRIC or certainly in other organisations subsequently, because we're not there yet. I mean, to be honest with you, the Australians who started their iCode, and I think the iCode was really the progenitor of all the codes that have gone on so far, have only just started to actually investigate bot metrics right now. And they're finding it extremely challenging based on all the knowledge that they've acquired over the last couple of years. So that's the status of the working group. Thank you.
Thank you, Mike. Any questions for Mike? Yes, sir. Alan?
You don't have nothing, you have some things, each of them doing different things. One of the things that's worked really well with metrics in other areas is pick one, any of them. Don't agree on it, just pick it and publish it internally so you don't, not to the public. And what happens is you get a coalescence of agreement. And since you've got them as players, if you give it to somebody else outside, you won't have access to the data. It's just an idea to, rather than just throwing up your hands and saying it's really hard, which it is.
I don't believe I mean, that work has actually gone on in Morg, and we've done that. But there's an extreme reluctance on the part of the ISPs to actually share and to allow that data, whether to be contributed for anonymous or otherwise publication. That is the challenge. They have to overcome the reluctance of the ISPs to actually share.
And is there any FCC action, behavior, discussion that could provide incentives for such sharing?
Alan, I'd rather not talk about FCC actions or behaviors. What we've done is we've asked ISPs and other stakeholders to come together in this multi-stakeholder environment and work on the problem, and that's what's happening. And so far, and we knew that the problem would be hard, and that's what we're hearing. The work that we've asked the CSRIC to do is ongoing. I think it's premature for anything more to be done at this point. I mean, it is a hard problem. Michael and I talk about this a lot, so I think that that's where things stand right now, and we're comfortable with that.
Any other question? Thank you, Michael.
Thank you.
Working Group 8, Robin Howard on E911 best practices.
Yes, good morning, Glenn. I'm on the phone today, and if someone could drive my slide deck for me, I'd appreciate that. So good morning, everyone. I'm going to give a quick status on Working Group 8, E911 best practices this morning. So if we could go to slide number 2. Slide 2 is the description and the summary of our work. We have 2 active teams still working on the 2 of the 3 items that we had in the charter. We're working towards our December deliverable, and we completed our first item in June of this year, and I'll cover those in a little bit more detail in the next couple of slides. So if we go to slide 3, please. Slide 3 is Working Group 8-2. This is a group that's chaired by Mary Boyd of Intrado. This team is currently working the bulk of our best practice review. They're meeting twice a week, going through the list of best practices, discounting and trying to focus and narrow the overall scope on the final work product. On slide 5, I'll go into a little more detail on the current status of this sub-team. So if I could go to the next slide, please. The next working group is Working Group 8-3. This is our PSAP and consumer best practices. This is chaired by Stoffels of AT&T. This team is actually beginning their work this month. They were kind of on a hold, waiting for some of the work being done by the Group 8-2, and that work is kind of coming to a close for them. We'll be able to get that team going this month. This team will actually be focusing on creating the structure, strategy, and concepts for 2 brand new categories of best practices. Our team members should expect to see an announcement in the next week or so on the start of this activity, and then from that point we should ramp up very quickly for our December deliverable for this one. Can we go to slide 5, please? So Working Group 8's current work activity. Working Group 8-2 is deep into review and scrubbing best practices for those best practices that are directly and indirectly related to 911 from a legacy and a next generation point of view. This team meets twice weekly and has at this point narrowed the list of best practices to be modified, modernized, or have simple remarks added to them for clarification from over 1,000 best practices down to around 414, and that number is getting a little bit smaller. This team expects to complete our second pass of the best practices on Friday of this week, and starting next week we'll begin actually moving into the final phase of the work, and that is the actual modification of the best practices. In the final phase, the team will modify best practices as necessary, and the goal is to provide any updates, clarifications, and to modernize as necessary. And that also the team is working on adding remarks to best practices that are not directly related to 911, but have an indirect impact. And a lot of these are in the area of next-gen 911 and cybersecurity and some of those types of best practices that if you perform those best practices, 911 is going to benefit on the reliability and the resiliency of implementation of those best practices. The other thing is with adding the remarks versus modification is it will also provide enhanced search features and information for service providers, network operators, and public safety segments as they go in and start doing searches in the best practice database for these types of best practices. And then finally, Working Group 8-3, which again will be starting up this month, their goal is to design and develop a new structure and strategy for these 2 new categories of best practices for PSAPs and consumer best practices. And so that'll be an important part of the overall package that we're trying to put together. And if we could go to slide 6, please. And what have we completed so far? In June of 2012, we did release Final Report Part 1, which was approved by Council, and that was intended to modernize best practices and consider best practices for next-gen 911 services that may be useful in preparing for natural or man-made disasters. And I know that since the derecho storm, I've had some contact with some folks about the final report and the checklist that was developed, and it was very positive feedback. So I think from that perspective, the report was very timely, and it'll be a good tool for service providers, network operators going forward. And then at this point, we've discounted over 600 best practices as not relevant for the activities that this working group is actually working on, and those are just those that are not applicable to 911 directly or indirectly. And then if we could go to the to slide 7. This is the final slide today, and this is our next steps. What do we have to complete yet? The next, starting next week, Working Group 8-2, which is again doing the bulk of our best practices, we'll begin our deep dive into the modification and modernization of the qualifying best practices that we've identified. Working Group 8-3 will begin this month on their new 2 categories, developing that structure. We're also needing to develop the process, how those best practices will be actually loaded onto a website. How are they going to be accessible to the public? How are they going to be accessible to industry? Those types of things. So that's the work that we've got going. We do have a deliverable for December 5th, and we'll also be beginning the final report preparation for that beginning in early October. So that's kind of my status update, so I'll open it up for any questions. Okay, Glenn, I'll turn it back over to you.
Yes.
One quick one. When we have a lot of best practices, when we have hundreds of best practices, people are trying to decide what to do, is there anything that your working group can do to prioritize these in a way that enables the users of the best practices to know what to do first?
Actually, I believe to answer that question, in the last CSRIC, there was a major work effort to create categories of best practices that rank them from most critical to, it was kind of like most critical to important. And that was actually incorporated into the ADIS and FCC website. So there is a method today to go in and prioritize those best practices. And we'll continue to dovetail on that with the items that we're coming up with.
Alan, that was Working Group 6 from CSRIC 2. I'll send you the report. Okay?
Thank you.
Okay.
Any other questions for Robin? Okay, thank you, Robin, for that update. And we'll go now to Working Group 10 with Thera Bradshaw and Gina Green.
Good morning. This is Gina Green, West Brent. I'm co-chair with Thera Bradshaw. I regret that neither of us could be there in person today, but I will be giving the report. As Jeff mentioned when he kicked off our meetings this morning, we've had plenty of opportunities to witness the need for 911 prioritization this year with the Del Recco in the eastern part of the United States, the fires that happened and occurred in the Midwest and western parts of the United States, and most recently Hurricane Isaac down in the southern and the western parts of the United States. And again, it just brings to mind the importance of ensuring that as many of our citizens and consumers can reach emergency services when they need them. Real quick, I'm just going to go over the charter of the working group. We've been chartered with exploring ways to ensure that 911 is available when emergencies and disasters cause a surge in the mobile network, to consider how 911 traffic might be prioritized in these instances, to look at the operational issues affecting public safety and how some of those might be mitigated, ways to reduce traffic load during the emergencies, exploring other things that may be available to us in the near future, hopefully, text to 911, some social media, some other short codes as 311. Next slide, please. As we pursue the prioritization, we're also looking into the network today. How the call flows are set up between wireless and wireline that actually get to public safety, and then a review of emerging technologies, 4G and LTE. Next slide, please. Our working group consists of about 14 of us, all of which I would like to thank for all of their contributions and participation. Everybody has been very active so far in providing contributions, both written and verbal, to discussions during the meeting. So again, I would like to thank the entire working group for participation so far. So far, just kind of a high-level bulletin of what we've been through. We've defined categories on different types of emergencies. We've kind of put them into advanced warning and no warning at all. Things that we know might be coming, like the hurricane, the Weather Service has predicted. Earthquakes, which we get very little warning on. Tornadoes, which we get very little warning on. National events, regional events, state, local events. So we've reviewed and defined these so that it would make it easier to put our thoughts and recommendations down on paper. We've also looked into and done some work regarding public safety operational issues and considerations. There was a study done last year that was published by Public Safety and Homeland Bureau on Next Generation 911 cost study that defined PSAP into categories of large, medium, and small. And what we see is that 80% of the public safety agencies in our country only have 1 to 5 call taker positions. So when we're talking about prioritizing calls to the PSAP, we have to keep in mind that the majority of the agencies that route and dispatch emergencies, on the average, only have 2 or 3 people there to answer the phones. We do have medium PSAPs with 6 to 49, and then large PSAPs of 50 call taker positions or more. As you know, the New Yorks and Chicagos can staff up more readily than can, the county sheriff in Iowa. So we've gone into some aspects of that. We've reviewed network architectures, both wireless and wireline, for call flows and congestions. And as a group, we've also looked at, and because of the latest storms and events we've had recently, we've had some data that we could review regarding what's working and what's not, and where those congestion points actually are in the network, and look at the reliability and resiliency of the networks today. We are just starting to get into talking about and providing contributions on the technical advancements of LTE and Next Gen 911. And then we have some further discussions to do surrounding consumer education and maybe some of the social media that might be available to them, or other methods available to them to get to emergency services in the event of disasters. Slide 6 basically just covers the contributions that we've already had, defining the categories, PSAP observations, network diagrams, and the use of text to 911, 311, Facebook even, for non-emergency type communications that could go out. We are working on drafting, pulling together all of the discussions and contributions that we've had so far into our draft report so we can see if we've got any gaps versus our overall objectives. We continue to have our biweekly calls and try and pull that all into a format. Our final vote is for March, so we anticipate having our draft review done by the working group by January 15th, and the report to the steering committee by February 6th, and the final report to the members by February 20th. And that concludes my status report. Does anybody have any questions?
Questions for Gina? No questions here, Gina. Thank you very much for your report. It's good, and We'll move to the final report update from Group 11 on cybersecurity consensus controls with Alan Poller and Marcus Sachs.
Thank you, Glenn. I was particularly taken by the way you opened this meeting with a context setting, because I think we sometimes forget how our work affects the rest of the world. So thank you for doing that. I do want to introduce Mark Sachs, who's sitting over here, who is my co-conspirator in this. Mark is one of the very rare people in the world who is a public policy official for a telecom company who is also very technical. He was the go-to guy in all the early attacks of the Joint Task Force on Computer Network Operations at DoD, and then the president made him the head of telecommunications, whatever, I remember, what was it, telecommunications, communications infrastructure protection in the White House for the country. So he had to go back on 9/11 and see what actually happened. And it's just nice to have a mix between public policy people and technical people. So thank you, Mark, for being willing to serve. We also have on this panel probably the top threat person in the country. He was the head of the NSA's Vulnerability Analysis and Operations Group, Tony Sager. Just retired after 34 years, and the head of the NSA at his retirement said, "This is my mentor on cybersecurity defense." So it's a strong group, and I'm sort of lobbying for others of you who might want to join, because it also has a mission that I think is central to what this whole group is about. So that was a little sales pitch for good people. You might get some interesting things out of it. Just back to Glenn's context setting. This last night, since the last CSRIC meeting, a couple of big things in context have happened, and they're both relevant. One is a man named Jonathan Evans, who is the head of MI5, the Director General of MI5. He never talks publicly. You can't find him out in the public, and he broke his silence 75 days ago and said, the new level of cyber attacks is remarkable. So a guy who never talks about it is saying that the level of attacks are skyrocketing. So this is, we can sort of pretend it isn't happening, but it is. And then the second half is, does it really hit the critical infrastructure, or is that all kind of well, maybe, and it can happen? And I can't imagine why we've gotten so little press coverage, but how many of you know about the Aramco attack? How many of you don't know about the Aramco attack? How many of you won't raise your hand no matter what I ask? So just for those of you who don't know, the best way to describe it is 30,000 bricks. So every single computer that manages the organization, that opens the doors, that runs the gates, that does everything, were turned into bricks in this attack. Permanent bricks, not bricks where you send somebody out to fix them. Permanent bricks. They're gone. If that had been Exxon, there'd be front page headlines saying America at war in cyberspace. The fact that it was in Saudi Arabia instead of the United States really shouldn't give us any confidence. So what I'm trying to say is, now this is a now issue. This isn't a well, maybe it'll be something we should take our time about. It's a really important issue, and central to it is, what are we doing to protect the telecommunications infrastructure from the kinds of attacks that have already hit the oil and gas infrastructure? So it's that. And to do that, we're taking the CSRIC 2 that were really well done by Ed Amorosa from Verizon, a really good collection of lots and lots of things you can do to protect your system, and we're matching it up against a fascinating list of things that were published by the Center for Strategic and International Studies. And I want to give you a couple-minute summary of it so you'll see where this is going. This started with a request from the Secretary of Defense to NSA about 4 years ago, where some really bad things, I don't want to talk about them, but really bad things that's happened in cyber inside the Pentagon, inside the Secretary of Defense's office, really bad stuff. And they wanted to stop it. And they had all these people giving them long lists of things you ought to do, but had no idea how to do them all. And they wrote a note to the head of NSA saying, can you tell us what we have to do first? What are the specific things that will actually protect our systems? And NSA published this, or not published it, they gave it to them, and I got word of it and said, can the world get access to this? And the answer was sort of, heck no. But John Gilligan, who was the CIO of the Air Force and the CIO of the Energy Department, and the head of the Center for Internet Security, took it and brought together the nuclear energy labs, the Department of the NSA red teams and blue teams, the JTF-GNO, just a lot of the people who know how attacks actually work, and said, can you vet a list of these, starting with what DOD did, but not publishing the DOD list, and create a list that actually are the first things people have to do. There may be 1,000 others to do, but what do we need to do now? It's what the CIA calls stop the known bads first. So it's what do we do with the known bads, the known attacks? And that became this thing called the 20 critical controls. And then it died. Everybody said, oh, wow, what a cool list. And then it died. And then about December of last year, the British, who had been the home of the ISO standards, this big group of standards, basically threw them out and said, we as a nation are going to standardize on the 20 critical controls because we can get them done. And they brought together CESG, MI6, all the critical infrastructures, and just last week you might have seen the story that they're doing that with all their commercial organizations too. And then just a few months ago, actually 6 months ago, DHS took the 20 critical controls and said that's what we're going to do to monitor and operate the federal government. We're going to stop trying to tell them to do everything and give them lists of 500 things to do and say these are the things we have to do and we're going to measure it every day. So we're not going to just talk about it, we're going to measure them every day. And then in June, General Alexander, the head of the NSA and a cyber commander, started giving public speeches saying for the first time the U.S. has a public-private partnership with a set of benchmarks that we can use. So what created this working group was, hey, we've got a long list of controls that CSRIC 2 had done. Can't we see how they map into the 20 critical controls and try to get them synchronized? So that's what this thing is about. And the purpose is so that people who have to protect machines know what to do first. Because if you look at a list of 400 things, what do you do? And I brought along, just so it's fun when you're on CSRIC, people will think you're an expert on cybersecurity. So I brought along for each of you a copy of the poster that has the British and the NSA rankings on all the 20 critical controls. You put on your wall, and you can then have everybody say, wow, you guys really know a lot about security. Or anyway, so that's the purpose behind it. Mark, do you want to add anything to that? Anyone? I'll pass these around. Anyone have questions?
No questions for Alan or Mark? All right. Well, thank you, Alan, for that report, and that concludes our updates. Really, the bulk of our meeting for today. On behalf of the council, I would like to offer our genuine thanks to the working groups and to the group leaders especially for the time and dedication you put in this effort. It's obvious there's been a lot of work done here, and this work it is unique work. It's work that I think will impact our nation. So thank you for what you're doing. Thank everyone for joining us today. I look forward to seeing you at the next CSRIC meeting that's scheduled for Wednesday, December 5th, 9 o'clock in this same meeting room. And with that, I'll turn the meeting back over to Jeff to close the meeting.
Okay, thanks, Glenn. And I also want to add my thanks to everybody for all your continued hard work and the quality that shows up in the reports that we're getting. So thank you for that, and we're looking forward to another 6 months or so of that, and then probably more as we go forward with the next CSRIC, which we're now in the process of chartering. So probably won't be the same folks, but maybe some of the same folks. Anyway, as Glenn said, next meeting is December 5th. It'll be close to holiday time, so town will be looking bright and colorful, and good time to be here. So we'll look forward to seeing you here then, and have a safe trip home in the meantime. Okay?
Thank you.